Hello, dear students. How are you? So my name is Divakar and I'll be taking you through the concept of kinematics today. Right. So it will not be a very detailed class as such, but I'll share with you what the absolute essentials are and what are the things that you need to surely like memorize and non-negotiable basically. So we'll try to cover the chapter called motion in one dimension, right? And we'll try to cover like the different aspects of it, like what is motion, what are the things that you need to remember in it, distance, displacement, velocity, acceleration, application of calculus in it, and then some graphs, some non-conventional ones, right? And we'll emphasize somewhat on like the sign convention thing and when to make take velocity zero, maxima, minima, and all those concepts, right? So without further ado, let's begin with the concept of kinematics. So as I told you in the concept of kinematics, our major focus will be in the concept of motion in 1D. So let me make it slightly thick. So this is motion in 1D. It has various names though. Sometimes you call it rectilinear motion, sometimes you call it motion in a straight line, sometimes you call it motion in 1D. But all of them means the same thing. Now in motion in 1D, if you want to understand them, first of all, you need to understand what is motion. So if you don't understand motion, you will not be able to understand the chapter. It's as simple as that. So first and the foremost thing that we'd like to understand is what do we mean by the term motion? So understand motion is change in position. But it's not that simple. So when you talk about motion and you say it's change in position, change in position, then change in position with respect to what? For example, I'm standing like I'm sitting on my chair and I'm seeing everything around me is like at rest. But if I go in space and I see the same things from space, then I'll realize that actually they are moving at a very high speed with the earth. So are they at rest or are they in motion? Are they changing position or are they not changing position? That becomes a very important question. So motion is changing position for sure. There is no question about that. But with respect to an observer. So if your observer is not well defined, you cannot define what is rest and what is motion. Now, when you're talking about an observer, it could be a person who is seeing the motion or it could be a reference point as well. So when we are talking about observer, it could be a person who is seeing the motion or it could be a reference point with respect to which you are defining motion. In either cases, it will be somewhere, a physical location. And that leads us to the second definition, and that is called frame of reference. So what is frame of reference? The region or zone where your observer is. A region or zone where your observer is there. It could be a place which is moving. So for example, you are standing in your balcony and you're seeing people moving. They're covering distances, right? They are changing their positions. So your frame of reference is your balcony. To be like in layman terms, you can call it ground. On the other hand, you can be in a car which is moving at a constant speed and you're seeing people nearby moving here and there. So then your frame of reference becomes your car. Lastly, you can be in a vehicle, right, which is accelerating and you see the people all around you, right? So there are three kind of reference frames where your observer can be. Number one, the first reference frame is called the inertial reference frame. So you can say inertial frame of reference. And now two reference frames come under this category. Number one, if the frame of reference is at rest. So if your frame of reference is at rest, it comes under inertial frame of reference. And if your reference frame is moving with uniform velocity or doing uniform motion, then also it comes under inertial frame of reference. Now try to think a bit why it's called inertial frame of reference. Because whenever you're analyzing motion, there is something called as inertia. And if the object is at rest or in uniform motion, that basically implies there is no net force acting on it. So inertia of the thing is maintained. And that is why the frame of references for which the inertia is maintained are called inertial frame of references. On the other hand, if there are frame of references where the inertia is not maintained, so for example, you are in a car which is accelerating, then you call it a non-inertial frame of reference. So non-inertial frame of reference, in layman terms, you can say accelerated frame of reference. Frame of reference. Now, the utility of this frame of reference you will study when I take the session on laws of motion. But understand, Newton's laws of motion are not applicable for non-inertial frame of reference. That is why non-inertial frame of reference is super important. So just as a hint, I'll write here, we'll do the explanation when we'll study Newton's laws of motion. But I can surely say at this point that these are the frame of references where Newton's laws fail. And that is why you need to introduce a concept of pseudo force. So more about this we'll discuss when we'll discuss laws of motion. So what we have understood till now, it's not only about changing position, it's also about your observer and where your observer is. Now, I'll write down a statement and then I'll explain that statement. So if I say motion is a relative term and is not absolute. So is this statement correct? Of course. Why? Because if you are talking about motion, I said that with respect to me, something could be moving, with respect to you, it may not be moving. So for example, if there is a person in the car, the person sitting next to the driver is not moving with respect to the driver. But the people who are seeing the car passing from ground, with respect to them, both of them are moving. So motion is a relative term. There is nothing like absolute rest or absolute motion. More about this we'll discuss when we'll discuss relative motion in one day. But let's say if the person moves. Now the next thing that happens is if the person moves, he'll cover some distance, which is basically the path length. And the person will also cover some displacement. Now, what do we mean by these two terms? Let's understand this quickly. So as far as distance is concerned, distance is the path length covered by person in, let's say, from point A to point B. So let's take an example to understand this. Let's say there is a person here A. He wants to go to some point B, but the route is something like he has to go 4 meters horizontal and then 3 meters vertical, and then the person reaches point B. So in this case, if I'll ask you what is the path length covered, you will say 4 plus 3, not a big deal. So you will say, okay, distance is the path length covered, and hence it's like 7 meters. But if I'll ask you displacement, then displacement is the straight line distance between 2 points. So if the person wants to go straight and reach point B, then the person will most probably follow this particular trajectory. And if you want to find out what is the length of that trajectory, then you can apply Pythagoras theorem. So Pythagoras theorem says perpendicular squared plus base squared is equal to hypotenuse squared. So if you'll apply that, you'll get 5 meters here. So what is 5 meter here? 5 meter is the length of displacement. So you can say displacement here in magnitude is 5 meters. Though the example is very simple, but it clarifies a few points about displacement. If you talk about reaching from point A to point B, there could be infinite paths you can follow. You can go up and then you can go horizontal. You can go to some other location and then travel to B. But if I'll ask you about displacement, are there any other possible displacement between these 2 points? No. If you change the direction a little bit, you'll reach somewhere else. If you cover some other length, then you'll again reach somewhere else. So between any 2 points, displacement is a unique value. And it's not only unique in the sense of length, it's also unique in the sense of direction. So you will have to, if you want to find out basically a displacement between 2 points, you'll have to fix your distance. So that means it's unique in the sense of magnitude also between 2 points. And it's unique in the sense of direction as well. Any other direction won't suffice. And that is why you may be knowing that displacement is treated as a vector. So if a person moves, he'll cover some length. And how many types of length you study? Two types. One is distance and the other one is displacement. Now let's see some more examples on displacement and distance. So let's say the first example is, there's a wheel here and the wheel is rolling. And after some time when I see the wheel is somewhere here. So if I take this point as A, after one rotation, the point reaches here and this point is A now. If I'll ask you how much displacement point A has covered, so understand, in order to reach at the topmost point, A has to cover half the circle. So meaning the length covered in that duration is pi times r, half of the circumference. On the other hand, if I'll ask you what is the length from the bottom to the top, you will say the diameter. And I know that the displacement is considered as from where you started and where you are, the straight line distance between them. So this blue line over here will represent the displacement. Now, if I want to find out the length of the blue line, it's cakewalk. You know that you need to apply Pythagoras theorem. So the Pythagoras theorem says that the displacement covered will be root of pi r square plus 2r. Now, there's a challenge question which I'm giving you, which you can try out and try to solve. That if you want to find out what is the distance traveled by point A, it will not be that simple. Again, I'm telling you, it's a challenge thing, and you can put your answers in the comments. That if I ask you what is the distance traveled by A, then the answer to that I'll tell you. You can cross verify, are you getting this answer or not? It should come out as 4. So this is how you find out displacement in case of a rotating wheel. On the other hand, let's say you have a bird flying. So there's a room, and in that room, you figured out that, okay, my bird is starting from here, right? It flies somewhat like this and reaches this point B. And I'm interested in finding out what is the displacement covered by the bird. So basically what I want to find out is what is the length of the body diagonal. Now, in order to find out the length of the body diagonal, first of all, you need to know what the side lengths are. So let's say the side length I've taken as A. Now, if I want to find out that displacement, think of one thing. If I know this length and I mark this point as C, then ABC makes a right angle triangle, where AC is basically the face diagonal of a square of length root 2A. And I know BC is A. So for this triangle, the hypotenuse length is what I'm trying to find out. And which is very simple to calculate now because I know the base in the perpendicular now. So if you apply Pythagoras theorem, you'll get the value of AB as root of A square plus root 2A whole square. So that will give you root 3. And that is the displacement you'll have. Like this, you can solve many other problems as well. For example, if a particle moves in a circle, comes back to the same location, then in that case, your distance is 2 pi r and your displacement is 0. If it covers half circle, then you can say your distance is pi r and your displacement is same as the diameter. If it covers quarter of a circle, then you can say your distance is pi r by 2 and your displacement is root 2r. So these are few simple questions which you can have in case of displacement. Can there be other situations as well? Yes, of course. If you, let's say, throw a ball from this point, it goes up and comes back and falls to the ground. If I'll ask you what is the distance, you will say distance is y plus h. But if I'll ask you displacement, that will only be h because the straight line distance between the initial and final point is h. So if I'll ask you here, what is the distance? You will say 2y plus h. And if I ask you what is the displacement, you can simply say h. So these are the few cases in which you can find out basically what is the distance covered and what is the displacement covered. So the last section in which like the question of displacement can come is if it's given as a function. So for example, if I have a function of x where x represents position as t square minus 2t, fine. And they want to find out like what is the displacement covered between 1 second and 2 seconds. So it's very simple. Displacement is basically the change in position. Why? Because if a particle is moving in a straight line and it was at x1 and finally it is at x2, then you know the displacement is x2 minus x1. So if I'm asking you between 1 and 2 seconds, what you can do is you can find out what is the value of x at 2. So if I substitute here, I'll get 2 square, which is 4, minus 2 into 2, which is again 4. So this gives you 0. And if I take at 1 second, what is the value? So 1 square is 1, minus 2 into 1. So that is like minus 2. So your displacement is 2 meters because that's the difference you have, right? And to the left. So I hope this thing is clear. Next concept that we have in the concept of basically kinematics is the concept of speed and velocity. Speed and velocity. In order to understand the concept of speed and velocity, you need to understand its utility first. Why is it important to study speed and velocity? So understand one thing, bacho. Whenever you are trying to understand movement, it's not only important that there is the change in position. There are other important things as well. For example, how fast that change is happening. What is the rate at which the change is happening? Are you covering 2 kilometers in like 2 hours, or you're covering it in like half an hour, or you're covering it like 10 minutes, or you're like super fast and you're covering it like seconds, which is like tough. So now speed and velocity, these are the two terms. They talk about the rate of change of distances. For example, if you talk about speed, it is distance by time. And if you talk about velocity, it's displacement by time. Super simple. Now about speed and velocity, there are two ways you can find them. For example, you'd go on a journey from point A to point B, which are let's say 500 kilometers away. If you cover that journey in 10 hours, you will see your speed was 50 kilometers per hour. But was the speed 50 kilometers per hour at all times? No. Sometimes it was more, sometimes it was less. That is the average speed you are talking about. But at each and every instant, was the speed same or the velocity same? No. So that is why when you talk about speed, it has been categorized into two parts. There is something called as average speed, and there is something called as instantaneous speed. Similarly, when you're talking about velocity, that means you're moving a straight line and you're covering displacements, they can also be of two types. You can talk about the thing as a whole. So you can say, okay, average velocity. And then you can have instantaneous velocity as well. Now, as far as average velocity or average speed is concerned, their values may be same, may not be same. When I say values, I'm talking about their magnitude. Of course, velocity will be a vector and it will not equate to speed. But if I'll talk about average speed and average velocity, they may be equal, may not be equal. Now, you may say, how is that possible? So let's take an example to understand this. If I have a particle A which starts from A goes to B, and this distance is let's say 100 meters, and this he covers in let's say 10 seconds. So if I'll ask you what is the speed, you will say, okay, magnitude of speed is 100 by 10, which is 10 meter per second. And if I ask you about velocity, since the person is moving a straight line only, you will say again it's 100 by 10, and that is 10 meter per second. So are they same in similar in magnitude? Yes, of course they are same in magnitude. But when is it possible? When the particle is moving in a straight line and not taking a turn. Let's take another example. Let's say the same person who moved from point A to point B, which is 100 meters away. After reaching that point, the person took a turn and came back to point A. So understand, it's a two-way journey from A to B, and then the same time it takes to go from B to A. So if I'll ask you what is the speed in this case, you will say speed is distance, total distance, which is 100 plus 100. So you get 200. And divided by total time is 10 plus 10, which is 20. So you will say, okay, there is no change in speed, at least. So 10 meter per second. But if I'll ask you velocity, will it be the same? So there is a trick now, because velocity is total displacement by total time. So velocity here is 0. Why? Because the total displacement is 0. So average velocity may be equal to average speed in magnitude. It may not be equal to average speed in magnitude. So this is something which you need to remember very carefully. And when they are equal, when it's moving in a straight line and not taking a turn. Now, what kind of questions you can expect in average speed and average velocity? So question category 1. A particle starts from point A, moves with a velocity v1, goes to point B, covering some distance s. Then from point B, the speed changes and it becomes v2, and again the same distance s, and reaches point C. Now, if I'll ask you what is the average velocity for this journey, the concept is really simple. You will say, okay, average velocity can be written as total displacement by total time. Now, total time is not known to you, but you know the velocities and the distances. So you can say, okay, time taken in A to B is distance by speed. So I can write S by V1. And similarly, time taken from B to C is S by V2. Now, if I substitute those two values here, like I write 2S divided by TAB plus TBC, then you will get the result as 2V1 V2 divided by V1 plus V2. You can verify it yourself. It's a simple result. I'm not saying you cannot start from scratch and derive these results, but if you remember this, your calculation becomes fast. Next is, if you have a journey in which you are starting from point A and having a velocity V1 and you move for some time, I'm not saying the distance, I'm saying you moved for 1 hour. Then you change your speed to V2 and then again you move for 1 hour. Of course, your speeds are different and you're moving for the same amount of time, your displacements will not be the same. So let's say for the first part, your displacement is S1, and for the second part, your displacement is S2. So if I'll ask you, what is the average velocity you'll have? Since it's moving in a straight line, average velocity magnitude will be same as average speed. But let's say I want to find out what is the average velocity. So you will say, okay, total displacement, which is S1 plus S2, and then divided by total time. So total time can be written as A to B and then B to C, which is 2 hours. So now if I substitute S1 as V1 into 1, S2 as V2 into 1 divided by 2, so you get V1 plus V2 by 2. Understand V1 plus V2 by 2 you can apply when the time is same, and 2V1 V2 by V1 plus V2 you can apply when the displacements are same. You can derive results for three parts as well, but the concept will still remain the same. You will not be able to memorize all the results that are there, but at least try to memorize equal time and equal distances, so that even if a complex situation comes, you will be able to like shorten it out a little bit by finding out average velocity for a part, right? So if let's say there are 4 parts, so for 2 parts you can find out average velocity, then other 2 parts you can find out average velocity, and then it becomes a 2 velocity problem. So sometimes in solving questions, it helps you immensely. Now, what is instantaneous velocity? I would have taken more examples, but I think due to shortage of time, I'll just have to move forward, right? So there is something called as instantaneous velocity or speed. Now, instantaneous velocity or speed is basically you are not interested in the whole part of the journey. You are only interested in a small segment of it. So, for example, you are turning from point A to point B, and in between, you pass from point C. So, I'm not interested in your overall journey. I'm interested only in that point C. What was your speed? So, in that case, your consideration is you are taking a very small distance and you are taking a very small amount of time, right? And you are trying to find out what is the basically division of those two. So velocity is defined as small displacement by small time. If you write it in a slightly fancy way, you can write it as limit delta t tends to 0 and delta x by delta t, but it doesn't matter. It means the same thing, that you are trying to find out velocity when the displacement is really small and time is also really small. Now understand there is some change here. If you're talking about average velocity, it may not be the same as average speed always. But if you take very small displacements, so for example, there is point A here and there is point B here, and you move like this. So in this case, your distance and your displacement are significantly different. But let's say you have point A here and you have very nearly point B here, and this is the curve. Then you won't be able to distinguish between the curve and the straight line. So that is why if you talk about magnitude of instantaneous speed and instantaneous velocity, they will come out to be the same. So magnitude of instantaneous velocity and instantaneous speed will be the same. So if you are given you the function, so for example, you are given you the function of x. Let me just change the color. Yeah. So if you are given you the function of x, for example, 2t square minus t, right? 2t square minus 4t, let's say. This is the function that is given to you. Now, there are a bunch of things that can be found out using this. First of all, they can say, tell me what will be the displacement covered in, let's say, 1 second. So you will say, okay, displacement in 1 second. So you'll say, okay, x at 0 was 0. X at 1, if I substitute, then 2 into 1 minus 4 into 1. So that becomes 2 minus 4, that is minus 2 meters. So if I'll ask you what is the displacement, displacement is the change in position. So you'll write x1 minus x0. So that will give you minus 2 minus 0. So that is minus 2 meters. Simple question. Second question they can ask you when they give you a function is what is the instantaneous velocity in that case. So you will say, I have just learned that if I differentiate this or I take a small value of dx divided by small value of time, I'll get that value. So I can say dx by dt. So differentiation of 2t square is 4t, right? And differentiation of minus 4t is 4. So if I ask you what is the velocity at 1 second, you will say 4 into 1 minus 4, which is 0. Velocity at 0, so you will say it was 4 into 0 minus 4, so that is minus 4 meter per second. So this way you can substitute different values of t and you can find out what is the velocity at any given instant. Now it's not only limited to this. Sometimes they ask you what is the time at which the particle will take turn. So understand the concept here. If a particle starts from point A and moves in a straight line, then the particle will only be able to take a turn if the particle stops at the turning location and then moves back. Although if it's a 2D motion, then the particle can go like this and take a turn without stopping. But in 1D motion, it is not possible without stopping. So whenever they ask you like what is the time at which the particle will stop, basically what they are asking is what is the time at which velocity will become 0? Or what is the point where the particle takes turn, where the velocity becomes 0? So you'll substitute, okay, I got the function as 4t minus 4 for my velocity. I'll put it as 0. So if I substitute 4t is equals to 4, so I'll get t equals to 1 second. So 1 second is the time at which the particle will take turn. Now they can extend this idea a little bit and they will also say that what is the distance covered in 2 seconds, for example. So in that case, if they ask you distance, you'll have to be extra cautious because distance will be magnitude of displacement from starting point to the turning point plus turning point to the final point. Let me illustrate this with an example. So let's say I throw a ball up. So if my ball goes like this, stops here and comes back. So in this case, if I ask you what is the displacement, you'll say 0. But what is the distance? Distance is actually a displacement from the starting point to the point where the velocity becomes 0 and then double of that. So in these kind of questions or functions, whenever it's given like find out the distance, you'll have to be extra cautious, right? And you'll have to see that whether the particle is taking turn in between or not. If the particle takes turn, then you'll have to solve it in parts. You'll have to see from where it's starting and where is the turning point, and then add from turning point to the ending point to it. And then you'll be able to calculate the total distance. If displacement is given, we learned how to find out instantaneous velocity, but the reverse can also be there. So for example, if they give you velocity as a function of time, how will you find out the displacement? So we studied that v is equal to dx by dt. That is the relationship between velocity and instantaneous velocity and displacement. Then you can write dx as v dt. So if I integrate this, so I'll get delta x that will be equal to integration of v dt. So if you are given with a velocity function and you integrate it, you get a displacement function. So differentiation of displacement, velocity, integration of velocity, displacement. Let's take an example to understand this. For example, velocity is given as, let's take the example which we took above, let's say 4t minus 4 only, right? And we are interested in finding out what is the displacement function. Now you may say x is integration of, or delta x is integration of 4t minus 4, and then you have dt. So this will become 4 taken out, integration of t is t square by 2, and then from minus 4 taken out, integration of dt is t. So this becomes 2t square minus 4t, which was expected as well. Now, few of you may see why you are not writing plus c, because it's a definite integration. You are finding out the change in position, so that constant gets cancelled out. You don't need to write it actually. I hope this will be clear up to this point. So in velocity and speed, what you need to study, basically the average velocity part you need to take care of. And after that, the instantaneous velocity part you need to take care of. After this, there is a quantity, and that quantity is called acceleration. Because the rate at which you move sometimes does not remain constant because of traffic, because you are feeling tired and all that, right? You can't walk any further. So your rate of movement changes, and acceleration is a measure of that. So acceleration basically tells you the rate at which velocity changes. Now, like everything else, like speed, like velocity, you can have an average acceleration, which is like delta v by delta t, and you can have instantaneous acceleration as well, which is like dv by dt, limit delta t tends to 0. Now understand one thing here, and I want to like emphasize on this, that acceleration's direction is not the same as direction of velocity. It's same as the direction of change in velocity. Now, what is the distinction between the two? For example, there is a particle which was moving to the north with a velocity v, and then took a right turn and again started moving with the velocity v only. So there is no change in magnitude of the velocity here, only the direction is changing. So let's call this as v1 and let's call this as v2. So if I'll ask you what is the change in velocity, you will say v2 minus v1. So if I represent it vectorially, I'll say, okay, this is v2 and minus v1. So v1 was to the like upward direction, so minus v1 will be in the downward direction. Now, if I want to find out what is the resultant of those two, it's this. So this will represent v2 minus v. So now understand why did I tell you this thing. If you have v1 and v2 as your velocities and you want to find out its change, then acceleration depends on the change. So acceleration will not be in the direction of v1, acceleration will not be in the direction of v2, acceleration will be in the direction of the change of it. So that means in this particular case, if I'll have to answer, I'll say it is southeast. That is the direction of acceleration you'll have. So acceleration is not velocity by time, acceleration is change in velocity by time. Similarly, instantaneous acceleration is dv by dt, but if I do a slight manipulation here, because I know another formula, which is v is equal to dx by dt. So from here, I'll get dt value as dx by v. Now, if I substitute this value here, you get another formula for instantaneous acceleration, and that is v dv by dx. So there are two formulas for acceleration as far as instantaneous acceleration is concerned. One is dv by dt, the other one is v dv by dx. So it's fairly evident, and you'll be able to like guess it as well, that if velocity is given as a function of time, then the formula you will go for is dv by dt. And if velocity is given as a function of x, then you'll go for the formula of v dv by dx. So depending on the need of the question, you will decide whether you want to go for dv by dt or v dv by dx. Now, few of you may believe that is it like different formulas, two different formulas we have, or is it like the same variation of a single formula? Actually, it is variation of a single formula. Let me explain you that thing. So for example, velocity is given as a function of x, right? And I only remember that there is a formula called dv by dt. So now you can see the variables here are like t and x, they are not the same. So differentiating them easily will not be possible. So what you will do, you will go for chain rule. And what does chain rule say? Chain rule says that if you want to find out a differentiation of this particular function, then you will differentiate this as usual, right? So you will write basically d of fx divided by dt, and then you will go with the multiplication of differentiation of your assumption. So basically dx by dt. So now you can see this is actually v, and this is actually, just one second, this is actually v, and this is dv by dx. So it's actually chain rule only. So whether you want to remember it this way or that way, it's actually the same form of dv by dt with chain rule. Now, next thing. If I have displacement, I can go to velocity by differentiating it. If I know velocity, I can go to acceleration by differentiating it. I can go in reverse as well. So for example, there is acceleration. If I integrate it, I'll get velocity. And if I have velocity, I integrate it, I get displacement. So this case, if you see, is very important as far as like calculus perspective is concerned. So acceleration can be written as v dv by dx, which basically implies v dv is equal to a dx. If you integrate this, you get basically integration of v dv is v square by 2 u to v, and this will give you integration a dx. So this is one thing you can remember. Second, if a is equal to dv by dt, then from here you can write dv is equal to a dt. So if you integrate this, dv integration is delta v, and that will give you integration a dt. So if you have acceleration, you can find out change in velocity. If you have velocity, you can find out acceleration, depending on what kind of function is given to you. Now, there is something called as equation of motion. Equation of motion. Remember, if I have a is equal to dv by dt, then dv can be written as a dt. On integration, this can be written as delta v, which can be written as integration of a dt. But if the acceleration is constant, it can be taken out and this becomes a dt. Now, what is the integration of dt? Integration of dt is t. So this becomes delta v is equals to a times t, and delta v is what? Change in velocity. So change in velocity is v minus u, that can be written as at. This you can take to the other side, so v becomes u plus 8. So this is what you call first equation of motion, which you may already be knowing. But my point here is, if acceleration is variable and given as a function of time or as a function of x, you cannot apply these formulas. These formulas are only applicable when the acceleration is constant. So for example, in case of free fall, they are applicable. So in case of free fall, they are applicable. There is no issue with that. Why? Because in free fall, you assume there is just one force, and that is gravity. And you also assume that that gravity is constant. It's not changing with height, which is wrong. But for small heights, you can take that approximation. So in case of motion under the influence of gravity alone, you can apply these formulas. There is no issue because acceleration is constant. But if acceleration is given as a function of time, you should avoid applying these formulas. Next rule that I told you just now was, acceleration can also be written as v dv by dx. If you cross multiply, right? So you get v dv is equal to a dx. If you integrate it, you'll get v square by 2, and let's say the speed is changing from u to v, and if a is constant, it can be taken out, integration of dx is x. Now when you substitute the limits and cross multiply, you will get v square minus u square is equal to 2as, and that is the third equation of motion. Or I derived it second, but it comes third generally. Then you have one more equation here, and that is third equation. So you know that v is equal to u plus at, and v can be written as dx by dt, which is equal to u plus at. Now cross multiply, so you will get dx is equal to u plus at into dt. Now if you integrate them, you get integration of dx as x, integration of u into dt is basically ut, plus at into dt. So a is a constant here, integration of t dt is t square by 2, and that is another equation of motion. Are we limited to these equations of motion? No. There are some more, and I'll tell you that as well. So the fourth equation of motion that you have is, let's say you have this as displacement. Here I'm calling x as displacement. In some textbooks, you will find s as displacement. So just remember the context. So you can write this as like ut plus, now you have at square. So you can write this as at into t divided by 2. Now what is at? At is actually v minus u from the first equation. At is v minus u. So if I substitute that, I'll get x is equal to ut plus at can be written as v minus u into t divided by 2. Now if you take LCM, you'll get x as 2ut plus vt minus ut divided by 2. Now 2ut minus ut will become ut. So displacement can also be written as u plus v into t divided by 2. This formula helps you immensely when you are dealing with displacement problems and initial and final velocities are given to you. So for example, they say that initial velocity of a vehicle was 20 meters per second, final velocity is 40 meters per second, it travels for 10 seconds. What is the displacement? So in that case, you don't need to go from the root of s is equal to ut plus half at square and all and find out acceleration and then substitute it. So rather than that, what you can do is you can just put the initial value, the final value divided by 2 into time. Done. Fifth and the last formula in the sequence of equations of motion is the distance covered in the last second. distance covered, or precisely actually it's displacement covered, because these are vector equations, in the last second. So understand what is the meaning of last second or any nth second. Let's call it nth second. Let's generalize it. So actually here what we are trying to say is this. If the particle travels for 10 seconds, then s is equal to ut plus half et square tells me how much distance the particle has covered in 10 seconds. It doesn't tell me what is the particle, the distance the particle has covered in 6 seconds or 7 seconds or 3rd second or 4th second. Here I'm interested in finding out what is the displacement covered in any particular second. I'm not interested in finding out what is the total displacement covered. So let's say I want to find out what is the displacement covered in the 5th second. So I'll find out what is covered in 5 seconds minus 4 seconds. If I want to find out what is the displacement covered in 9th second, so 9 minus 8. Similarly, if I want to find out what is the displacement covered in tth second, then I can write this as st minus 1. Now you know how to write down the formula for displacement in t seconds. So you can write this as ut plus half at squared, and minus, you will write ut minus 1 plus half into a into t minus 1 whole square. Now, if you simplify it, right, which is a very easy task, you will end up with a result looking like this: u plus a by 2, 2t minus 1. This formula is very crucial, and I want all of you to remember this, that if you want to find out displacement covered in any tth second, then you can find out using this formula. So for example, if a particle starts from rest, right, and starts falling, and I ask you what is the displacement covered in the 1st second, so you will say, okay, u is 0, a is, let's say, 10, gravity 2 into 1 minus 1, so which is 1 only, so a by 2, 10 by 2, so this will become 5. Then if I ask you what is the displacement covered in 2 seconds, so you will say, okay, 10 by 2, which is 5, and 2 into 2, 4, minus 1, 3, so it will become 15. Then if I'll ask you for the 3rd second, 25, then 4th second, 35, and so on. So you'll find out a pattern here. The pattern is, if a ball is falling only under the influence of gravity, then the displacement covered in nth seconds or like consecutive seconds, it will always be in the ratio of 1:3:5:7:9, and so on. And this is a very important result. If you remember, like for example, if I say what is the displacement covered by the particle in 4th second, so you'll say what is the 4th odd number? I have 9 into 5, 45, done. What is the displacement covered in, let's say, 10 seconds? So you'll find out a 10th odd number, and then you'll multiply it with 5. So if you remember this ratio, things become very simple, and you will be able to calculate the results very quickly. On the other hand, if you try to develop some intuition about acceleration, then see. If I say my particle is being projected with a velocity of 30 meters per second in upward direction and a gravity value is 10, what does that mean? So this basically means that every second, the velocity of the particle will get reduced by a factor of 10. For example, if the initial velocity was 30, and after 1 second, I ask you what will be the velocity, you will say 20. After another 1 second, 10. After another 1 second, 0. So you know, at 3 seconds, the particle will reach the top. And then it will start falling. So after 1 second, now the gravity is supporting it because the velocity is in downward direction. So the velocity becomes 10. After another 1 second, 20. After another 1 second, 30. So that makes a few things clear. Number one, velocity at the same horizontal level remains same. Number two, time period, if you want to find out the time taken by the ball to go up in the absence of air drag and the time taken by the ball to come down will be the same. And total time you can find out just by seeing that how the velocity is changing. So for example, in this case, it's 6 seconds. Not only this, you can predict some more things. For example, in the 1st second, after 1 second, the particle was here. After 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 6 seconds. If you take any horizontal level and add their times, so for example, 2 plus 4, 1 plus 5, or 0 plus 6, in all the cases, it's coming out as 6. So T1 plus T2, that means the time at when the balls were same horizontal level. If you add them, you always get equal to the time of flight of the ball. Can we calculate something else from it? Yes. If let's say the ball is falling for 3 seconds and I know the result that in 1 second ball falls for 5 meters, in the second 15 meters, in the 3rd second 25 meters. So I do not need to calculate it now. I can simply say that the total displacement covered, right, while going up and coming down is 0, of course, but let's say one-way displacement is what you want to find out. So in 1 second, it covers 5, 2 seconds, 15, 3 seconds, 25. So if you add them, you get the displacement as 45 meters. So just by having some intuition about the motion and remembering some standard results, make the calculations very simple. You'll be able to calculate a lot of things without utilizing any formulas. I hope up to this point, everything will be clear. Now see, bachcho, if I want to see the last part of it, right? We have last 10, 13 minutes. So I'll focus on something called as graphs. So if we take up the example of graphs, then in case of graphs, understand one thing, there are some graphs which are called conventional graphs. For example, displacement versus time graph, velocity versus time graph, acceleration versus time graph. And there are some graphs which are not that conventional. So for example, V square versus X graph, acceleration versus X graph, and so on. So first of all, in a graph, what you can do? So for example, if I have a graph Y here and I have X here, then if this is my curve, then if I ask you what is dy by dx, then dy is the small value of y which you will take. For example, here if I take a very small element, this is called dy. And if I take a small element in horizontal direction, this is called dx. So if I'm trying to find out dy by dx, or you can say differentiation of y with respect to x, basically I'm trying to find out tan theta for that. And tan theta for any segment has a name, it's called slope. The other thing that you can find out in a particular graph is, so for example, I have another graph, you have y here and you have x here, and the graph looks like this. Then you can say, okay, what does y into x represent? Y into dx represents. So you will say y is the value at any given point. Dx is the small length along x. And if you multiply those two, you are getting area of a rectangle there. And putting integration in front of it basically means you are adding all of them. So y into dx represents area of one rectangle, and putting integration in front of it means you are adding all the rectangles. And if you add all the rectangles, you get the area under the curve. Area under the curve. So what does it leads to? So if you are given it a function and you want to find out what is the differentiation of that function, you apply formulas. But if you are given it the graph and you want something that differentiation can give, you'll find out slope. So finding out slope in case of graph is same as doing differentiation in case of basically your function. So many a times, if you represent your equation in graphical format, then solving question becomes very simple as compared to if you solve it using equations. I'll give you an example for it. Let's say there was a question in JEE Advanced Ones. The question was, if a particle starts from point A with an acceleration alpha, then moves with the same acceleration for some time, then moves with a constant velocity and then deaccelerates, right? No, it was actually accelerates and then deaccelerates. Let's say that constant thing is not there in between. So in that case, if you go by equations, you'll apply S is equal to ut plus half at square for both the parts, then V is equal to u plus at and all that. But understand, if you do it using graph, then you can draw just a single slope for acceleration, positive, then a single slope for acceleration, negative, and find out the area that will give you the change in velocity. Overall point is, if you can transform a question into a graphical question, solving that question becomes simple. So I have here two graphs, right? Two graphs, and I told you what are the two things you can find out in any particular graph. Now let's see different graphs gives us what if we try to find out these two things. So first graph that we have, most common one, we have displacement versus time graph. So if I have any kind of graph like this, and I want to find out what this graph can give me, then one thing that graph can give me is ds by dt, where s represents displacement here. And the other thing it can give me is area, which is integration of s into dt. Now ds by dt, if you try to find out rate of change of displacement, it's called velocity, so it can give me something. But area, s into dt, there is nothing like integration of displacement into time, so it will not give you anything. So is it not? It's not like all the quantities that you get from a graph are important. You just need to focus on the important ones and try to utilize them. Simple. Now, your slope, which is important in case of s versus t, could be positive. It could be a negative one. It could be an increasing one. it could be a decreasing one. So graphs could be of various kinds, shapes and sizes. What you need to focus on is what does the angle represent. For example, in the first case, you can see tan theta is positive and it's representing a constant slope. That means my velocity is constant and positive. In the second case, the slope is negative. So that means my velocity is representing a negative velocity, and slope constant means it's a constant negative velocity. The third graph represents a situation in which the angle is increasing. And if angle is increasing, that means my velocity is increasing. So accelerated motion. In the fourth graph, you can see the angle is decreasing with time. So that means my velocity is decreasing with time. So the concept is very simple. You just need to see, first of all, from a graph, what the slope can give, what the area can give. You will get to know that, okay, what is important and what is not important. Once you are clear with that aspect, you can see, apply it like in any of the graphs, and you'll get to know that whether I need to, for example, focus on the area part of the graph or the angle part of the graph. The other graph, a conventional graph only, is VT graph. Again, you can have all kind of variations in this, right? But what does the slope represent? If I'll ask you, it will be dv by dt, which is basically acceleration. If I'll ask you what will the area of this graph represent, so v dt, which is basically displacement. So this is like in conventional graphs, the most important one, because slope and area, both of them give you something. The third graph that you have is called acceleration time graph. In acceleration time graph, if I'll ask you about slope, slope is rate of change of acceleration. It does represent a quantity, but not there in our syllabus, so not important. And if I ask you about area, it's acceleration dt. So that means this area part is important because this is providing me change in velocity. Change in velocity, not velocity. Understand this thing. There was a question once, and in the question, they gave AT graph. And they said that the initial velocity is some, let's say, 2 meters per second. What is the final velocity? And many students find out the area and they wrote that as the answer. That was not the answer. That was equal to v minus u, and you had to add 2 to it. So remember, area under acceleration time graph gives you change in velocity. It doesn't give you velocity. Fourth and fifth, these are the two graphs which I recommend a lot, right? These are non-conventional ones. So first one is, let's say, A versus X graph. So if I'll ask you what will the A versus X graph will give you, so you can say the slope of this graph will be dA by dx, won't give you anything. But if I ask about area, it is integration of A dx. Now, if you remember from our derivation, integration of A dx was actually v square by 2 from u to v. So it is basically representing v square by 2 minus u square by 2. And if in this area, you multiply mass, then it becomes mv square by 2 minus mu square by 2. There was a question on this as well, that if you are given with AX graph and they are asking you what is the work done or what is the change in kinetic energy, because work done can be written as change in kinetic energy, then in that case, how will you find that out? So area under AX graph gives you that v square part, and then you multiply it with the mass given in the question, and that gives you work done or change in kinetic energy. So be very cautious about AX graphs, because sometimes you imagine X as t and then you solve it in your way and you get a wrong answer. So be aware of this thing. The last graph that I would like you to remember is a v square versus X graph. Now, what does a v square versus X graph give you? So if I have a graph like this and I want to find out like what is the slope of this graph. So slope of this graph is basically d of v square by dx. So this is basically a differentiation of v square with respect to x. Is first of all, you differentiate v and then chain rule dv by dx. Now, if you see this thing, this we have seen somewhere. This is the alternate formula for acceleration. So slope of v square by x graph is important because it gives you twice of the acceleration. Is the area important? So I'll say area is integration of v square dx, right? And not very important. So last part of it, sometimes you need to find out equations also, right? Those type of questions are rare, but if they ask you equation, then you need to know how to write it down. I want to teach you, like, for the shortest of time, I'll take just one more concept and then I'll leave you guys, right? And that concept is finding out average. Finding out average value of a function. Now, whenever they say average value, they can give you a question in two categories. Number one, they will say, okay, velocity as a function of time is given, and you want to find out average velocity. And second, sometimes they give you velocity versus time graph, and they ask you what is average velocity. So understand this thing. If I want to find out average velocity using graph, I need to know the displacement first. And displacement is basically the area under the graph. So area under the graph divided by time. But remember, area under the graph is also same as what? Integration. So this leads us to the answer to the first question. That if you want to find out average of a given function, step is you integrate that function first and then divide it with the time for which the function was present. So this is the last topic that I wanted to discuss, right? In the next class, probably I will discuss some questions related to kinematics 1D motion. So till then, bye-bye, take care. I'll see you in the next session. I hope you have enjoyed this session. If you have enjoyed this session, please share, like, comment and all, and I'll see you in the next class. Bye-bye.